Hello, 7th grade algebra students. It's Mrs. Trombley. Today it is time for lesson 7-6, factoring polynomials using the GCF. I know you thought that GCF was done and over with from a long time ago, but the reason that you learned that so long ago was so that you could use it today. It's an exciting day. The purpose of today, why do you want to factor a polynomial using the GCF? Well, sometimes you're going to be given polynomial equations, and they're not going to be written in factored form, and you just learn how to solve them in factored form, right? So if you can factor the polynomial, then you can solve the polynomial equation when it's not written in the form that you need it in. So that's kind of the purpose of it. So the front side of this sheet of the notes, we're just going to practice factoring them. And on the back side, I'm actually going to give you some equations to solve using this method. So the front part, just factoring the expressions, and the other side of this, we're going to solve the equations. Okay, so step 1, you have to know how to find the greatest common factor of the terms in the expression. So let's say I gave you, which I did, 6x cubed plus 15x. I know that you are used to finding the GCF of numbers like 6 and 15, right? The greatest common factor. Or I just look at it as, what is the largest number that will divide evenly into both terms? So when I see a 6 and a 15, when I look at those, I know that 1 divides evenly into both, and so does 2, and so does 3, and I think 3 is the biggest number. If you look at this and you're like, I have no idea, how do you do the GCF again? I'm going to kind of show you the long way now, and then later on you're not going to have to show me all these steps, but it's good to show them on notes so that you have it. I have this term, 6x cubed, and the term 15x. We're going to list the factors of each, okay? So 6 factors of 6, 1 goes into 6, 2 goes into 6, 3 goes into 6, 4 does not, 5 does not, and 6 goes into 6. And when you have x cubed, that means that you have 3 x's. So the factors of x cubed are x, x, x. That's a little different than you've seen before. Okay, now we have 15x. The factors of just the 15, 1 goes into 15, 2 does not, 3 does, 4 does not, 5 does, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And the factors of x are x. Now, we're going to look for the largest factor that they have in common. And I see that as far as the digits go, they both have 3, right? And then they both have an x. So the GCF of 6x cubed and 15x would be 3x. They both have at least one x, that's why that x gets included. So that's going to be your step 1. You're going to look at each term that's given in the polynomial, and you're going to figure out what is the largest amount that will divide evenly into each term. Then your second step is to use the distributive property to write a polynomial as the product of the GCF and its remaining factors. So product means multiplication, right? So I'm looking at what are the factors I can multiply together to get this. So all we have to do to figure this one out is we're going to write 3x on the outside, and that's what we're removing from each. So to figure out what goes inside of those parentheses, I know, so this 3x is because I know that one of the factors is the GCF. And now I need to know what other factor can I multiply this by to get the product of this. Okay, so to get the first term, 6 divided by 3 is 2. And remember, you just learned those lovely little laws of exponents, right? If I'm dividing and I have the same base, don't you just subtract the exponents? So 6x cubed divided by x to the first power, I would just take 3 minus 1, so I'm left with 2x squared. Bring over your addition sign. 15 divided by 3 is 5, and x divided by x is 1. They cancel out. That's it. This is the factored form of that. And when you have this, didn't we just learn in the last lesson that I could say, well, 3x equals 0 and 2x squared plus 5 equals 0 and solve both of these equations and I can figure out what the solution is? Yes, maybe not the squared part of it, but we'll get to that too, don't you worry. Okay, so this is the factored form, that's the goal. Ready to try some? Okay, ready or not? It's time. Okay, I just want you to write each one of these polynomials in factored form. So step 1, we're going to look at What is the largest factor that will divide into 2x squared and 18? And with this one, it's 2. So up in the corner, I'm going to write GCF equals 2, because that's great to have in notes, in my opinion. To figure out how to write this in the factored form, I'm going to put the 2 on the outside because I know the GCF is one of the factors. To figure out what goes inside, I divide each term by the GCF. So 2 divided by 2 is 1, and I'm left with an x squared. And 18 divided by 2 is 9. And that's it. That's all you have to do for this beginning part. All right, look at letter B. Okay. To find the GCF, and again, if you wanted to list one of the charts like we did up here and list out all the factors, you can totally do that. That is a strategy that will work. If GCF is a weak area, then I would maybe go on, just go do some online practice with locating the GCF, calculating the GCF, and seek that out because you're going to want to be able to do it quickly. You're going to want to just be able to look at the 15 and the 10 and say, hey, I know that 5 is the largest digit that divides evenly into both of those. So 5 is the number part of the GCF, right? Now, if you were to list out all of the y's here, 15y cubed has 3y's, 10y squared has 2y's, right? How many y's do they have in common? They both have 2, right? So that means my GCF is going to be 5y squared. 5y squared. I'm hoping that makes sense because if this has 3y's and this has 2, they can't both have 3y's in common because this one doesn't have a third y. They both at least have 2y's. So my GCF is 5y squared. I'm going to write that on the outside. And to figure out what goes on the inside, I'm going to kind of scribble these out. You need to divide both terms by 5y squared. So 15 divided by 5 is 3. And when you take y cubed divided by y squared, you just subtract the exponents. 3 minus 2 is 1. So I'm really just left with 3y. Remember, you don't have to put the 1. Write an addition sign. Now let's do this one. 10 divided by 5 is 2. Y squared divided by y squared, any number divided by itself, is 1. So we're done with that one. All right, next. We've got 2 more of these, and then we'll solve some equations. Okay, I'm going to keep change this. And maybe you're thinking, wait a minute, Mrs. Tremblay, I think there's a typo because there's not a number other than 1 that goes into 3 and 14. I know that. There isn't. There's not a number. And it'd be kind of silly to write 1 on the outside of the parentheses because when you multiply 1 by something, it doesn't change it, right? There is something that divides evenly into both of these terms, though. Do you know what it is? I wish I could hear you. It's x. Do you see how this term has 2 x's and this term has 1 x? Don't they at least have 1 x in common? So the GCF of this is x. They both have x in common. So I'm going to write x on the outside, and I'm going to divide each term by x. So 3 divided by 1, because it's really 1x, is 3. And x squared divided by x, this would really be like x to the first. 2 minus 1 is 1. So I'm left with 3x. Plus negative. When you take x divided by x, it's gone, and negative 14 is left. If you wrote this as x times the quantity of 3x minus 14, even better. They're both satisfactory to me, though. This is fine. All right, last one of these. 21n to the third minus 18n squared. And don't factor, you don't need to factor out any negatives. Don't worry about the positive, negative business. Just give me positive numbers that you would factor out. So I see 21 and 18. Looking at those digits, the largest number that divides evenly into 21 and 18 is 3. And this one has 3 n's and this one has 2 n's, so they both have at least 2 n's. So we can factor out an n squared because they both have at least 2. I'm going to write my GCF on the outside and then divide each term by that GCF. What's left goes on the inside. So 21 divided by 3 is 7. N cubed divided by n squared is n. Plus negative 18 divided by 3 is 6. N squared divided by n squared is 1. All set. And again, if you wanted to write it as this, it means the same exact thing. Okay, The final step to this set of notes today is to solve equations in factored form, and we're going to use a zero product property. So turn your page if you haven't done so already. I'll zoom out for just a moment to talk about this stuff up here. It says that, basically what I said earlier, you've learned to solve polynomial equations in factored form using the zero product property. When a polynomial is not written in factored form, you're going to use what you just learned to write it in factored form, and then you can set your equation equal to 0 and solve it out. Okay? So, take a look at this first example here. I have 3x squared plus 21x equals 0. Okay? And first off, I want to see that these terms are all on one side together equaling 0. That's good. That's what you want. So at this point, I want to figure out the GCF of 3x squared and 21x, so I can write this in factored form, because I need factored form to solve the equation. Okay, the largest digit that will divide into 3x squared and 21x. I know between 3 and 21 it's 3. And then they both have at least one x. So our GCF is going to be 3x. To figure out what goes in the inside, I divide each term by that GCF. So 3 divided by 3 is 1. X squared divided by x is x. 21 divided by 3 is 7, and x divided by x is gone, and this equals 0. This looks very familiar, doesn't it? This is just like what you did, hopefully yesterday or the day before. Hopefully we're on track. So the two factors of this polynomial, the two factors in factored form, one of them has to be 0, or both of them, in order for this to be set equal to 0. So that means 3x can equal 0, and x plus 7 can equal 0. Divide by 3, x is 0, and subtract your 7, x equals negative 7. So basically what we did yesterday, once you get it written in factored form. Sorry, scooch it up a little bit. All right, take a look at this next one. And this is why you see so many examples. This one's different because I have an equal sign. I don't have a 0 on one side. Before you start factoring this, I need you to collect all the terms on one side and make sure that 0's on the other. So let's put them all on this side. To get rid of this negative 6g from this side, I would have to add a positive 6g. So the equation we're really dealing with here is 4g squared plus 6g equals, hey, what happens when you add opposites? Yep, you get 0. Now, doesn't this look like all the rest of them that you've seen? It sure does. This is not in factored form. We need to get it into factored form. So the largest number that will divide evenly into 4g squared and 6g. 2 is the largest digit that will go into the 4 and the 6. And they both have at least one g. So GCF is 2g. That means I'm going to divide each term by that. 4 divided by 2 is 2. G squared divided by g is g. 6 divided by 2 is 3. G divided by g is 1. And you don't need to write 3 times 1. That would be silly. Equals 0. Now, it's just like lesson 7-5. If this times this equals 0, then either this is 0 and or that's 0. So solve them both. This one you divide by 2 and g is 0. And this one now I've got a little two-step. It's okay. It's no big deal. We're going to start off by getting rid of that positive 3. So 2g would equal a negative 3. And then we'll divide by that coefficient. And negative 3 divided by 2, yes, it's a decimal, and yes, that's okay. Negative 1.5. So g is 0. I know, not quite a nice little circle all the way around, but hey, it works. All right, let's try 2 more. The last one looks really crazy. You'll be fine, don't worry. Okay, here we go. They're not all on the same side together, right? I need them to all be on the same side together. And with this one, I just want to show you that it doesn't really matter what side you collect them on. So this time I'm going to collect them all over here on the right side instead, because I like this y squared highest degree term to be first. So rather than subtracting 6y from 18y, I would rather subtract 18y from 6y squared. All right, so let's get rid of this by adding a negative 18y or subtracting 18y, same thing. 0 equals 6y squared plus negative 18y. Same way. It's okay that the 0 is on the left. Honestly, it's no big deal. I'm going to do this the same way. What's the largest digit that will divide evenly into 6y squared and negative 18y? Well, as far as the 6 and the 18 go, I know that 6 is the largest digit. So I'm going to put my 0 equals. Okay? And then they both have at least one y, right? So that means that y is part of the GCF. I need to divide each term by 6y. 6 divided by 6 is 1. Y squared divided by y is y. Negative 18 divided by 6 is negative 3, and y divided by y cancel again. So, all that's left to do now is say, okay, well, if this times this equals 0, then either 6y equals 0, or y plus negative 3, and or y plus negative 3 equals 0. We're going to solve them both out. Divide by 6. 0 divided by 6 is 0. Here we would add a positive 3 because that's how you cancel out a negative 3. And y will be equal to 3. At least these ones end up in a nice little straight line across the bottom with my circle. Thank goodness. I don't know if I could have handled it. Okay, last one. It's okay. It has 3 terms in it. Oh, there it is. It was hiding. All right. Same kind of thing here. I want all of the terms on one side and 0 on the other. So I'm going to go ahead and move this one over here. To cancel out a negative x squared, I would add a positive x squared. I know that negative x squared plus positive x squared cancels out, so I've got my 0. And now over here, it's just combining like terms, right? This is just saying 12x cubed plus 5x squared plus x squared. 12x cubed doesn't have any like terms. I'm going to rewrite it. But 5x squared and x squared go together. When you add them together, you get 6x squared. All right, oops. I don't know why I made that a 2. I'm glad I caught that now. So there, that's cubed. It's a big, weird-looking 3, but it is. Okay, same thing now. It's not in factored form. I need it to be in factored form in order to solve it. So, largest number that'll go into 12 and 6 is 6. And if this one has 3 x's and this one has 2, they both have at least 2 x's. So, x squared is going to be part of my GCF. To figure out the other term, I have to divide each one of these terms, or to figure out the other, polynomial, by 6x squared. All right. 12 divided by 6 is 2. X cubed divided by x squared is x. 6x squared divided by 6x squared. You don't have to know what x is. Just know that any amount divided by itself is 1. Now, we've got our 2 factors here. Either one or both end up equaling 0. So 6x squared could be 0, and 2x plus 1 can be equal to 0. Okay, now maybe you're looking at this and you're like, well, I don't know what to do. Just do this how you normally would. Normally you would divide by the coefficient, right? So we get x squared equals 0. This is not really, you don't even have to know how to solve these kinds of equations yet with the squared. What number squared will be 0? Yes, 0. So x equals 0. This one, I'm going to add a negative 1 to each side. That looks like a 7, but it's not, I promise. And 2x would equal negative 1. Divide by 2, and x equals negative 1/2. And if you wanted to write negative 0.5, it would not be wrong because they have the same exact value. All right, we'll apply what you have learned tomorrow in class. See you then.